Okay, hi everyone. How are you all doing? Today we have another Codeforces round, and today is a Div1 plus Div2 round. I mean, there is a Div1 round, along with it, there is a Div2 round. So, yeah, I will be participating in Div1 today, and let's see if I can maintain my candidate master and sort of just save it. Yeah, I think I will have to do like if I'm able to do two problems really quickly, then I think I can save candidate master. Apart from that, if I am able to do three problems slowly as well, yeah, I think then also I will be able to save it. But it is kind of difficult to do three problems in Div1, so I'm not aiming for three problems here. Two should be fine for me. So let's see how this one goes. Okay, so here we go. Problem A. That consists of n pastures connected by one directional routes. Each road has a weight representing the time it takes to go from the start to the end of the road. The roads have negative weights, could have negative weights, okay. Where the cows go so fast that they go back in time. Okay. However, Farmer John guarantees that it is impossible for the cows to get stuck in a time loop when they can infinitely go back in time. Okay, so that means there is no negative cycle. Also, each pair of pastures is connected by at most one road in each direction. Okay. Unfortunately, lost the map of the farm. All he remembers is an array D, where Di is the smallest amount of time it took the cow to reach the ith pasture from pasture 1 using a sequence of roads. Okay. The cost of his farm is the sum of the weights of each of the roads. Okay. Needs to know the minimal cost of a farm that is consistent with this memory. Alright. Connected by one directional roads, each road has a weight, right? Impossible for a negative weight cycle. And Di is the smallest amount of time it took the cows to reach the ith pasture from pasture 1 using a sequence of roads. Alright. The cost of his farm is the sum of the weights of each of the roads. Minimal cost of a farm that is consistent with this memory. Okay. 0, 2, 3. So from 1 to 2 we can have an edge of weight 2, that is fine. And from 2 to pasture 3 the time of 1. And from pasture 3 to pasture 1 with the time of -3. Oh, alright. And from pasture 3 to pasture 2 with the time of -1. Okay, I see. Right. So the thing is that if I add a positive edge, I can also add a negative edge corresponding to it. So that should be fine. And 0 and we have this, right? So we can have uh, a negative edge of that same weight. Yeah, this seems fine. So All right. So for any point that we are able to reach, we can add a, you know, a backward edge from that point to the first point of negative weight. So the answer can be 0, fine, but can we decrease the answer as well? Let's see. So if we try to decrease the answer, let's say the weights are 0, 1, 2, and 3. Let's sort them first of all. So from 0 to 1, I can add an edge of 1. From 1 to 2, I can add an edge of 1 again. And from 2 to 3, I can add an edge of what? I can add an edge of 1 again. And from here to here, I can add an edge of minus 2. And similarly, minus 1 here. Right, and from this one, I can add an edge of minus 3 can be added here, then minus 2 can be added, and then minus 1 can be added. Okay, so if I had something like 0, 2, 3, and let's say 6, then what I can do, I can add an edge from 0 to 2 of edge of weight. Achha, okay, this has to be, just a minute, this has to be 1, this has to be 2, this has to be 3. So here I add an edge of 2, and here 1, and here I add an edge of 3. So from here to here I can add an edge of minus 6 first of all, and here I can add an edge of minus 4, right? Yep. And here I can add an edge of minus 3. So this is fine. So do I need to sort the differences or the actual value? Okay. So this minus 3 can come once. That is fine. And this minus 1, how many times can it come? It can come twice. Because going from here to here will be giving me once, and from going from here to here will give it to me once. Okay, right. Apart from that, that particular value is already there. So I think I can just sort the differences here, right? Right, so first of all I sort them, and then I create a difference vector. Right, and then what do? I add difference dot pushback ARR at I minus ARR at I minus 1. Right, and for the sum part, LL sum equals to 0, I can do this plus equals to difference. Right, I mean, why wouldn't you have a line graph here? Why would you have it differently? Creating a line graph actually creates the maximum negative things that you're adding. So this should be fine. So I sort this vector first of all. Right. And let's sort it like this. Right, so actually I don't need to add this because this is already getting subtracted, right? So here what do I do? Here I simply, okay. So if I have 0, I mean, let's consider them as nodes. I have 3, 2, and I have 1. So here I will have -1 once, and here -2 will be added twice, and -3 will be added thrice, right? Right. So here I can just add them. Sum plus equals to difference. Minus equals to sz at difference minus I. So here we have 1, 2, and 3. So this one gets added twice. Right, yes. Okay, let's try to test this. Sum plus equals to -2 it is giving. So let's try to debug this difference array. 2 and 1. So this has to get added twice, right? Let's debug sum as well. Sum is coming out to be 3 here, which is fine. What about this edge? I don't think we need to add this. Do we need to add this? No. And then -1 here. So this has to get added twice, this has to get added once. No, both of them have to get added once only. Okay. So if I have this, then this is 3, this is, okay, let's consider it like this. This is 2 and this is 1. So first of all, these edges are already added. I don't have to care about them. Now this gets added once. No, that is already subtracted, no? This 2 is already subtracted, that 3 is already subtracted. Okay, what were the edges that they were adding? 2 to 3 with a cost of 1, that is fine. 3 to 1 with a cost of -3. 3 to 2 with a cost of -1. Right. So this -2, how many times is it coming? It is coming twice. And this -1, how many times is it coming? So 2 and 1 I add and I subtract them, which is fine. After that, I have a -3 going back. Okay, this is very complicated. This I have already removed from the answer. So how many times will this come? This will come once. So if I've already removed this part, then this remains. So for the first one, this has to be 0. And for the second one, okay, this edge is getting, if I keep it like this, so then I have a -2, which is fine. I have a -1, which is fine. So I don't need to take care of this. But what about this? I do need this, right? So from 1, I can go all the way till here. Then I can go for this as well. I can go for this as well, and I can go for this as well. Like for all of them. Right. So how many times will this edge be getting added? 1 times. Right. How many elements are remaining? That is the whole point. Okay, this is very, very tricky. I don't have any idea what is happening here. So if I have like another edge here, this is satisfied. What about this edge? And what about this edge? Let's keep it 3, 2, and 1. Okay, let's do it for 4 nodes. Then it will be a lot clearer. So I have these edges. These are already satisfied by this. Right. Now what I can do is, if I consider this node, it is already done. I cannot add any edges further, right? But for this one, I can add this edge. Right. And now for this one, I can add this edge and I can add this edge. Right, cool. So this part is done. Let's remove this. What about the other nodes? So this whole part is getting added once. Then this whole part is getting added twice. Right, yes. Oh, cool, cool. Val equals to diff at 0. plus equals to diff at I, and then I do sum minus equals to I. Okay, this is coming out to be fine, but there were 3 test cases here, right? Okay, so if right, so this seems fine here, but let's try it out for a bigger test case. Let's say we have 0, then we have 2, then we have 5, and then we have, let's say, 6. So how will I be adding edges? I will be adding the edges like this: 0 to 2, 2 to 5 of 3, and here, right? I cannot sort that. That sorting is not right, right? So, I mean, this should be written like this. So I have an edge of 2, 3, and 1. So this is already satisfied here. Now what are the other edges that I have? I have this edge, which is -5, and I have this edge, which is -4, and I also have, oh, okay. So there seems to be an issue here, because then I also have this, right? So I added this first of all, and then what did I do? This is, okay, so this one is getting added how many times? This one, this edge is going to added twice, right? Yeah. So let's skip this part. This part is coming once, which is fine. Then both of these edges are getting added once, and then when we come here, this edge gets added once. In fact, this edge gets added twice. This edge gets added once, right? So if I just had another one, then uh, if we go here, if we go here, if we go here, right? So this edge will get added thrice. This edge will uh, this edge will get added once. This edge will get added twice. This edge will get added thrice. This gets added thrice. This gets added once. This gets added once, and then after that, this particular edge, this gets added twice, and this gets added thrice. Okay, let's just consider it like this, that even if I add the difference, so I have this, and then for this one I have this and I have this, right? Now for this one I have this, I have this, and then I have this as well, right? So how many times will this edge be getting added? That is the question. This got added once here, then once here, and then once here. Right, what about this? This got added once here, then once here, here. So n minus 1 times, right? N minus I times. 0, 1, 2, 3. This edge will get added once, right? Yeah. This one is getting added thrice, right? And this one twice. No, this is 1, this is 2, this is 3. Here this is 1, this is 2, and this is 3. This is 1, this is 2, and this is 3. Every edge is getting added equal number of times. All right. So if I talk about, yeah, so I had to do this as well, right? Right, so let's test it for this test case. Uh, I have 0, 2, 5, and 6. Okay, so this edge is like 2, this edge is like 3, and this is 1, right? So yeah, I mean this one will get added how many times? This one will get added n minus 1 times. Right. So let's test it for this test case. 4, 0, 2, 5, and 6. So I have 2 plus 3 plus 1, which gives me 6. Yeah, this is fine. So let's try to submit this now. I don't think that extra sorting was required anyway. Okay, wrong answer on pretest 2. So there is some logical issue, I guess. Okay. So if we have 4 here, I don't know, why would you never need a line graph here? I think a line graph should do it. Okay. Okay, I think each edge is not getting added equal number of times. Is that the case? This is very confusing. Right, so let's see how many times each edge is getting added. It is getting added equal number of times, like n minus 2 only in every case. Let's try to extend this here. Then we have this, uh, this, and then this again. So what is interesting is that this edge now gets subtracted more number of times. But it was getting added only once, right? I think I've missed something here. So here this edge, right, 1, 2, 3, and 4. What about this one? This is 1, 2, 3, 4, 5, and 6. I think I've missed something here. For the last one, it is, I think, n minus 2. What about this one? This is 1, 2, 3, 4, 5. This was 1, 2, 3, 4. And then this is like 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5, 6. Oh, this was also an edge, right? So now we have 1, 2, 3, 4, 5. And here we have 1, 2, 3, and 4. Yeah, because you can only put it for 4 in 4 ways, right? Yep. But for this one, it is sort of like a palindrome here. Each edge is not getting added equal number of times. That is the whole issue. So if this is n minus 2, then for all the times this edge is going to get added, that is n minus 2, that is fine. But there are other ways as well, right? One, two, three, and four. N minus 1 times, in fact. And what about this? This will get added n minus 2 times, first of all. And then it will get added how many times? N minus 3 times now. Because for all these, that is fine. This is n minus 2. And then n minus 2 again, right? This one will get added similar number of times. So I don't know what are they trying to achieve here in this question. Let's try out problem B instead. All right, so that was like one time n minus 1, right? This is like 2 times n minus 2. This is like 3 times n minus 3. And then this is like 4 times n minus 4, right? So this is like a palindrome here. Okay, now this is coming out to be 15. So let's see. So do I not have to, let's bring that back. So I was saying n minus 1 times here, but I've also added it, right? Yeah. So let's try it for the case that we have here. This is 0, 2, 5, and 6. So 0, in fact, let's keep it like nodes. 2, 3, and 1, right? Now I have this, I have this, and I have this, right? And then for this one, I have this, and I have this one as well. 2, 3, and 4. 1, 2, and 3. So this is like minus 12 itself here, then minus 6 here, and minus 3 here. But I also have a 6 here, so we can neglect this. I think this is fine now. Let me test it for this case as well. It should be fine here, but still. Yeah, let's submit this now. Okay, finally. I don't know. This was really very tough for me to look at this thing. I mean, observe that I was missing out on this test case. Apart from that, what I've done here is really very greedy. So, I don't even have a proof of what I did actually. But yeah, still, like one problem is better than nothing. So I guess it's okay. Moving on to problem B. And this is a tree problem. So something that I like. But yeah. I think there is some other solution to this problem as well. Because people seem to be solving it really fast. Initially, when no nodes are marked, a node is equiprobably chosen and marked for the entire tree. Okay. After that, until all nodes are marked, a node is equiprobably chosen and marked from the set of unmarked nodes with at least one edge to a marked node. Okay, it can be shown that the process marks all the nodes in the tree. Fine. The final array A is the list of nodes in order of the time each node was marked. Find the expected number of inversions in the array that is generated by the tree in aforementioned process. If you're given a tree, you generate an array from the tree by marking nodes one by one. Initially, when no nodes are marked, a node is equiprobably chosen and marked for the entire tree. Right. After that, until all nodes are marked, a node is equiprobably chosen and marked from the set of unmarked nodes with at least one edge to a marked node. Okay. And also talking about this previous problem, I was doing something like, I don't know, maybe it can fail on the system tests because this is 10 to the power 4, this is 10 to the power 9. So I don't know if this will fit or not. So this is like 10 to the power 5. A equals to A divided by 2 into A divided by 2. That is the maximum. And A into equals to 10 to the power 9. I think this can fail. Yeah, this can fail. Because the number that I'm adding, it can just become huge. I don't know. So if I'm lucky, this will run, but this has a very high chance of failing. But the thing is that all these differences, they cannot be so high, right? All of them cannot be 10 to the power 9 because the overall limit there was 10 to the power 9. I don't know. This can fail as well. I mean, I don't think I should be spending time on that. But yeah, let's look at this problem. The final array is the list of nodes labels in order of the time in which the node was marked. Alright, fine. Find the expected number of inversions in the array that is generated by the tree and aforementioned process. The number of inversions in an array is... Okay. Look at this, man. Huge numbers. The arrays are almost fixed. If node 2 is chosen, uh, then the only array is this. If node 3 is chosen, then the only possible array is this. If node 1 is chosen, then the arrays are 1, 2, 3 and 1, 3, 2. and are the only possibilities and are equiprobable. Right. So all of them are equiprobable. That is fine. Okay. So there is this tree, and you pick up the first node. It is totally your choice, whatever node you want to pick. Yeah, that is what I was saying. But this is not equiprobable. Yeah. So all these three possibilities are equiprobable, and then it becomes like, yeah. Okay. So can I iterate on the number of inversions that I want? The number of inversions here can be n square, and no nodes are marked. A node is equiprobably chosen and marked for the entire tree, and after that, until all nodes are marked, a node is equiprobably chosen and marked from the set of unmarked nodes. Okay. Find the expected number of inversions in the array that is. Okay, what if we have this array? Let's consider this here. And you will have an inversion when you put a number that is like, if you put a number, you can just, think about what are all numbers that haven't come till now. So that will be adding on for inversions, right? So here I have 1, 4, and then I have 6 here. So if I just start with 6, can I do some sort of DP here? Okay, can I treat this thing like, a contribution problem? Let's say if I pick up two nodes, U and V, right? So if I pick up two nodes, let's say U and V, and yeah, we can treat them like this, that U is less than V. I mean the labels. So whenever V is coming before U, I will have an inversion, right? So here, what will be the probability that a V comes before U? That is what we need to find, right? Right, right, right. So if I just treat them like this, that I have what do I call it? I have a U here and I have a V here. Then if I just consider this thing like this, then I will have something like this, right? I mean, all these nodes, I don't know how to explain this, but yeah, this will be something like this. And then I want V to come before you, right? And when will V come before you? The first case is that you choose the first node to be V, right? In that case, V is coming before. Another case is that if I choose any node from here, right? If I choose any node from the subtree of V that does not move towards U, then right, then again I will have a, again I will have V coming up before U, right? And what else can I do here? Like all these nodes, if I choose any of them, let's say there are X nodes here in the subtree of V, then this is like X by N. So N square into 1 DFS, yeah, this should be fine here. 8 times 10 to the power 6 should be fine. But what are the other ways that V can come before you? So if I go here, let's say I come to this node, that this node is getting marked, okay? So all these nodes here, I really don't care about them. What I need is I need to reach from this node to V before I reach from here to U. This is what I want. I don't really care about all the other nodes. So here the question comes whether you will choose this before this node or not. Right, yeah. Okay. So this is like the subtree here, and this is the subtree here. This is U and this is V. And I am saying the value of V is greater than the value of U. So there will be an inversion between U and V provided V comes before U, right? So if I choose any node from this subtree, I am done. Right, that will be one possible way. So the probability of that will be X by N. Now, oh right, in fact I don't need to consider this subtree. I can consider for every node that if I'm here on any node, let's say, right, if I pick this, so is U closer to me or is V closer to me? That is the whole question now. Right. So if V is closer to this node already, then the answer is 1 by N into 1 because it will be creating an inversion here. Right. Now, if I consider this node and I consider the path from here to U and the path from here to V. So there will be one point where they will switch, right? So I don't think I need to consider these nodes as such. What I can do is if I'm picking up any node from this subtree, then the answer is, X by N times 1. If I pick up any node from this subtree, then I will have to come till here first of all. Right. Now, what is the probability that I reach here before I reach here? I mean, sorry, what is the probability that I go to V before I even go to U? That is what I need to consider here. Okay. What is the probability that I go to V before I go to U? So both of these nodes are equiprobable. I can choose any of them. Right, yes. I can choose any of these nodes. So let's say there are, t nodes here. That means, including this, there are t nodes. And there are m nodes here, including this v. Right. So I need to go to v before I go to u. What is the probability of that? As soon as I move to one direction, my probability of reaching there will, increase. Okay. So if I just consider it like this, that I have u here and I have x here and I have v here. Right. Now, what is the probability that I select this one instead of this one? Well, it is simply half, right? Both of them are equiprobable. Right. Now, I need to reach v before I go to u. Okay. So let's say I want to travel from x to v in how many steps are here? Let's say m, and here let's say we have x steps. Okay. I want to travel here in m steps exactly. So what is the probability here? Like choosing this instead of choosing this one is simply half, right? Yeah, it is simply half. And if I choose all of them correctly, this is half to the power m. Now let's say I decide that I will be taking m plus 1 steps. Okay, this is slowly actually going towards order of n square. But still, if I say that I want to go in m plus 1 steps, then from the first m steps, I can pick up any one, right? So this is like c to the c of m1 because I can pick one of them, and then it's like 1 to the half to the power m plus 1, right? Now if I say that I want to go in m plus 2 steps, what does this mean? This means that this means I will have c of m plus 1 and I will have to choose 2 out of them, right? And here I will have half to the power m plus 2 then. Oh, all right. And if I say that I want to reach in m plus x minus 1 steps, there cannot be m plus x steps here. Because if you travel x steps here, then you're already, exceeding the limit as in. So this will be c to the power m plus x minus 1. Here you will have x minus 1 and half to the power, yeah, this is tricky, no? Like this whole equation is, oh, okay. Okay. Let's try to form this equation. Maybe there is some pattern that we can exploit here. So if I come here and let's say the distance here is t and here it is 1, right? So I will have to travel all of my distances towards right only in that case. So that will be like c to the c of t0, and this will be half of t. Now if I come here, then there are two ways to go from here to here, and one of them is c of t minus 1, 0, half into t minus of power of t minus 1, and then you can have c t minus 1, 1, because out of the first, if you say that you want to go right also, then this will be the thing, right? Half to the power t. Oh, this seems like something can be done here. Okay, just give me, right. So now if I talk about this point, then I have c of t minus 2, 0, and then I have c of t minus 1, 1. Sorry, this should be t minus 3, right? No, this should be t minus 2 only. C of t minus 2, okay. Because now I'm doing, how many steps? I'm doing one extra step here. So C of t minus 2, I will have to choose 1 here, and half of, so this is like t here. This is t minus 1. Right, and then there will be one other way, which will be C of t, C of t minus 2, 2, and This should actually be t minus 1, right? Okay, I will have to solve it on a pen and paper. Okay, so I kind of have an approach now, but there is some formalization that I need to do. So I have like 55 minutes. I think I can spend another 15 minutes, you know, finding out all the formulas. Okay, I think I have a good formula here as well, but there is like just too much that I need to code now. So let me just look at the standings once. Okay. So there is like just a lot that I need to code here, but still I think I will be able to do it in 50 minutes. Right. So what do I need to do now for right? So here my v is simply j, int u equals to I, v equals to j here, and then I need to find the path, right? So vector int path. I need to find the path from u to v. Right, that's right. And then I need to do additional DFSs again. Okay. So I have u comma edges comma v, and the parent here is -1. and I can even like pass the path here. And I have a path here, right? Okay, so if start equals to end, then path dot pv start, and then you return. Right, otherwise you do this edges at start. So if s said at is greater than 0, then what do you do? Then you simply just path dot pb start return. If I is not equal to parent, then you do dfs of I comma edges comma end comma start path. If sz at is greater than 0, then you break. Right, let's just find the path first. Right, let's try it out for this test case here. DFS1 it should be. Right, so let me first of all debug I comma j as well. Because I need this path to be first of all correct, only then can something happen here. So from 0 to 1 it says 1 comma 0, that is fine. 0 to 2 it says 2 1 0, so I will have to reverse this, right? Semicolon. So from 0 to 1 I have 0 1, which is fine. From 0 to 2 I have 0 1. Okay, from 0 to 2 that is fine as well. From 0 to 3 there is just a simple path from 0 to 4. So then you go to 1 first of all, then you go to 4, right? Or instead from 0 to 4 this is fine, right? From 1 to 2, that means from 2 to 3 the path is simple, this only, right? So here we're doing fine now. These paths seem to be fine. From 4 to 5, that means from 3 to 4. How do we go from 3 to 4? First of all, I go from 3 to 2. Oh, just a minute. From 4 to 5. 4 to 5. That means I need to go from 5 to 6. So I go from 5 to 2 first of all. Then I go from 2 to 1. Then I go from 1 to 6. So this is fine as well. Right, yeah. I hope this is fine. I mean, this is how I find the path every time. So this should be fine. And then what do I need? Now is the game here. So there are just like a lot of formulas here. I will have to see how to. Okay, first of all, I need all these values, right? So For the last one, I don't want to come back here. Right, so I think I can mark them all visited. Right, this should help. Mm, visited at I equals to 2. All right. Values at k equals to dfs of path at k, comma edges, comma visited. Right, let's look at this again. Path is fine, we've reversed it. And then we're finding the number of values, I mean number of nodes in each of its subtree, right? So dfs this should be int, right? Uh, dfs of I, comma edges, comma visited. Okay, this should be count 1 plus equal to. Right. So there seems to be some issue here. Let's first of all okay, this seems fine as well, but the issue seems to be here, right? So if not visited at I, visited at I equals to 1, right? This should have been the case. Now I need to debug the values. So now we can have a good understanding of what is happening here. Debug path. So let's look at this tree only. So when we talk about the path from 5 to 6 in this one, this is this path, and here the answer is 1, then 2, then 2 again, and then 1 here, which is fine. What about from 4 to 5, 4 to 6? So I have 1 here, and this should be 1, 2, 3, 4. Fine. This is fine as well. What about from 4 to 5? So this should be 1, 2, 2, and 1. Okay, all of this is fine now. And I need to consider everything in LL. Okay, let's change all of this as well. this path also has to be, I guess, right. So now all of this is fine. I can still debug the path and values just to be sure afterwards. Now what do I need to do? So I can skip the very first number here. So for right. So now first of all the answer has to be answer equals to can I even store these values? Uh, powers of 2. And we can also store the inverses as well. Right, now we are fine. So here what do I need to add? First of all, I need the probability, right? So I also need this inverse thing here. Right. So answer equals to answer powers of 2 1 2 3 4 5 6. So like 6 minus 1. 6 minus 1 will be 5, but no, this is 6, but the distances are 5. So no, this is fine. Zero, 1, 2, 3, and 4. So here the path length will be 1, 2, 3, 4, 5, 6. Minus 1, right? Yeah. Into okay. Now what is the values here? Instead I can treat them like whole probabilities only. Values at k comma n comma mod. In fact, it should be inverse of n. Okay, right. Right. So that is just one part of it. We're done with that. Okay, now I also need the combinations, right? So what do I do for that? No, I only need this. Okay, so for int that, okay, so fact at I equals to normal I comma fact at I minus 1, and I fact at I fact at I comma mod. Right, now we're done with this. Now we need the combinations. So for int I equals to, let's take it LLM. So I only need it from one, right? I mean, who am I even talking to? Like, I haven't told you all the formula. So plus equals to, in fact, not plus equals to, I can do it mod combinations at I. I comma j comma, what else do they need? And mod I fact, and I have mod. Right, this is fine now. What else do I need to do? Here at the end, I also need to do this combinations at I. Uh, inverse power of 2. So this is fine. Inverse power of 2. I plus 1 and so this is fine. Then C3 I add this and this. Okay, I also need the suffix sum here, right? Okay, cool. Suffix at k. Suffix and values at k. Right, now this is fine. In fact, I need a prefix here, I guess. No, this is fine. Right, so now here if the number was 6, then here it should be k. Suffix is fine because we need it till here. But then how many are there, right? Okay, mod null of this end. what is the actual answer here? Okay, the answer is different, but still. I think there is a very slight issue. I will have to yeah, like I cannot say if there is a slight issue or not because these values are totally random. So I have this answer equals to 0. Okay. Powers of 2, and then we have inverse powers of 2. So LL inverse n I have found, right? So then I have powers of 2 equal to val, okay, right? Combination, this is the factorial part, right? And here I have Cij equals to combination of Ij mod add. Cool. Right, so from 0 to 1, this is the right path. So I want V to come before U, right? Yeah. 0 to 1, 0 to 2 is fine, and 1, 0, 2, this is fine as well. Okay, how much time is remaining first of all? 20 minutes. I need to speed up now. Yeah, this is fine. Values at k inverse mod. This is the probability. Final. Done. Okay. Then this should be from 0, right? I mean, no, this should be from 1 only. Right. Powers of 2. And why am I doing powers of 2? Shouldn't this be inverse powers of 2? Okay, is this answer coming out to be fine? Yeah, this is coming out to be fine. I don't know if I will have to check the rest of the code or not. Oh, okay, cool. So like the last test case that I'm testing, and then I will be submitting. Oh, cool. So I think I can submit it now. But like I'm doing a lot of operations, so I'm not sure if, you know, I won't get a TLE here. Okay, wrong answer on test 4. So this is actually strange, like the first 3 test cases were working fine. But still. size of path minus k. So this is like 1, 6 minus 1 minus 1, which is fine. Oh, do I need to actually go till here? Yeah, I need to go till the last, till the very last. This is fine. Then how about the suffixes here? C11. K is greater than or equal to 0. Suffix at k plus 1, values at k. This seems to be fine. And then I start from 2. Yeah, I actually start from 2 then. Okay, what if I do this question, how much will my rank improve? Yeah, it will improve by a lot. Values at k mod. Then for this, the combination will be size. Yeah. Suffix at k. P2, P3, P4. This seems to be fine. I don't know where is this going wrong. So I have edges here, powers of 2, inverse powers of 2. Okay. NCR of IJ. Shouldn't this be n minus 1? It should be, right? Why was I taking input till n? This might be an issue. Let's see. So I got no other, choice other than to, submit here. I don't know if this was actually creating that issue or not. Okay, wrong answer on test 4 again. Okay, what if I only have one node here? Yeah, what if I have two nodes? What is the probability? The probability is simply half, right? Is there some other issue here?